Okay, let's mix it up a little bit. And now let's give somewhat of a word problem. Assume that y is a normally distributed random variable with a mean of 5 and a standard deviation of 4. Okay? So y is normally distributed with a mean of 5 and a standard deviation of 4. Okay? So we see this kind of distribution. Here's y, here's mean 5, here's standard deviation 4. And let's say we want to know what's the probability that y is less than 11. What's the probability that y is less than 11? Here's 11 out here, and we want this area. Okay, that's the probability that y is less than 11. What we need to do is convert this normal distribution to a standard normal distribution. Okay, so here's our standard normal, mean 0, standard deviation of 1, and we want to calculate how far away is 11 from 5 in standard deviation units. Okay, so our little value of z is going to be here somewhere. And what is that little value of z? We use our z-score, which is y minus mu over sigma. How far away is this value of y from its mean in standard deviation units? Okay, so it's going to be 11 minus 5 over 4, which is 6/4 or 1.5. Okay, we want this area. This area is equivalent to this. That says that the probability that y is less than 11 is equal to the probability that z is less than 1.5. Okay, so this is a pretty straightforward calculation now. We just need to go to our lookup table and find the area between 0 and 1.5. Okay, we go find this area, we add that to 0.5, and we have this whole area. Okay? So what is that value? That is 0.4332. Okay? Go down to row 1.5, over to column 0, that intersection, 0.4332. Okay, so this area, 0.4332. This area from 0 to negative infinity, 0.5. So our probability, the probability that y is less than 11, which is equal to the probability that z is less than 1.5, is 0.5 plus 0.4332, which is 0.9332. Okay? So for this normally distributed random variable y, roughly 93% of the observations, 93% of the realizations lie below 11. Let's take a look at another one. Let's say we wanted to know for this random variable y, mean of 5, standard deviation of 4, what's the probability that y is greater than 0? Okay, what's the probability that y takes on a realization that's greater than 0? Okay, well, we need to convert this. We can't do anything with this on its own. We have to convert this to the standard normal distribution. Okay, we have to convert this value on the y-axis down to something here on the z-axis. So how do we do that? With the z-score. Y minus mu over sigma. Okay? That's 0 minus 5 over 4, which is negative 1.25. Okay? Negative 1.25. This value right here on the z-axis, negative 1.25. That says that 0 lies 1.25 standard deviations from the mean to the left of the mean. Okay? So the probability that y is greater than 0 is equal to the probability that that z is greater than negative 1.25. If we go look that up, this area right here, in the z lookup table, we should get a value of 0.3944. Okay? And we know this area is 0.5. Okay, so we know this area 0.3944, this area 0.5. We add those two together, and that is 0.8944. Okay, so what's the probability that this y value lies above 0? What's the probability that we get a realization that lies above 0? 0.8944. Roughly 89.5% of the realizations of random variable y lie above 0.